All right, question number 2. Are freshman psychology majors just as likely to change their major before they graduate compared to freshman business majors? So it says just as likely. So this is going to be an equal or not equal to sort of scenario when we do our null and alternative hypotheses. Then we have 365 of the 637 freshman psychology majors from a recent study changed their major before they graduated, and 387 of the 718 freshman business majors changed their major before they graduated. What can be concluded at the zero point zero 0.01 level of significance? Okay, so this, because we're talking about a number out of a total and another number out of a total, we actually have two proportions for this one. So we want to do a two proportion z-test. So when it says what type of test, we've got here a two proportion z-test. And in terms of what that's going to be on the calculator, that's also the two proportion, but they just put prop z test. And this one's going to be the sixth choice when we actually get over to the test part. Okay. Before we actually dive into the calculator stuff, let's figure out what important information do they give us. They actually gave us two x values and two n values. So I'm going to talk about the business majors as sort of all the sub one, and I'm going to talk about, oh, sorry, not the business majors, but we're going to talk about the psychology people first. Those are going to have the little sub ones after them. And then the business are the second people they talk about. So we're going to put little sub twos after them. So for my X1 bar, or not bar, this one's just an X1. Sorry, no bars on this one because we're not doing means, we're doing just numbers. So we're going to have an X1 and we're going to have an N1. And then we're going to have an X2 and we're going to have an N2. So when they say that 365 of the 637 freshman psychology majors change their major, then my 365 is the X1 value, and the 637 is my N1 value. And then they give us 387 of the 718 freshman business majors. So these ones are going to be these numbers here. So 387 is the X2, and the 718 is our N2. So when we do these ones, in order for us to be able to continue, we actually want to go ahead and get a feel for what those proportions actually are. So if I took the 365 and I divided it by the 637, that's going to give me my p hat number 1. So I'm going to check what that is. So 365 divided by 637 is going to give me 0.57. So over here, I'm going to put P1 hat is 0.57. So that means that my Q1 I can get by doing 1 minus that 0.57. And I got 0.43. I'm going to do the same thing with my X2 and N2 here. So I'm going to do my P2 hat then. I'm going to take the 387 and divide it by 718. And we got about 0.54 if I round it, which means that I can get the Q hat then by doing 1 minus the 0.54. And that'll be 0.46. Okay. Why are we doing this? Because we have a condition whenever we're doing the proportion problems that we have to check that the n times the p and the n times the q are bigger than 5. And we have to do that for this n and this p and this n and this q as well. So I'm going to go ahead and just check that right now to make sure we can move forward. So I'm going to take that n value, 637, and multiply it by 0.57. and just make sure I got more than 5. I got 363 and some change, definitely bigger than 5, so we're good there. And then I'm going to take the 637 and multiply it by the Q, 0.43, and I got 273 and some change, so definitely bigger than 5. So this set's all good. I'm going to check this set now. I'm going to take the 718 and multiply it times the p hat, 0.54. And that gave me 387 and some change, definitely bigger than 5. And then we're going to take that 718 and multiply it times the Q, the 0.46. And we got 330 and some change, definitely bigger than 5. So we're good to go. I can move ahead with this test, but we always got to check that just to make sure that it's appropriate for us to move forward. So now that we've got that, we're going to write our null and alternative hypothesis for this example. Because again, we're just saying, are they just as likely to change majors, and we're not saying more likely or less likely, then we're going to just use an equal sign and not equal to sign. So my null hypothesis and my alternative hypothesis, we're going to have p's involved. This is going to be P1 is just equal to P2. And for the alternative hypothesis, it'll be P1 is not equal to P2. Okay. So what is our test statistic? We said this is a two proportion Z test, so I'm going to get this number from my calculator, but I know it's going to be a Z. And the other number that I'm going to get from my calculator is a P. And then we're going to move forward with decision making. So calculator time. I'm going to back up to this part up here so that I can see the things that I'm going to need to enter. We're going to go to the two proportion Z test in our calculator. And so we're going to go ahead and hit the stat button. You're going to arrow over to the tests and go down to two proportion Z test. That's the 6th choice, and hit enter. And the first thing it wants you to enter is the X1. So you're going to enter 365. The second thing it wants you to enter is the N1. So you're going to enter the 637. Then it wants the X2. So you're going to enter the 387. And finally, it wants the N2. You're going to enter the 718. So that's it for the number part. Then they want us to figure out, do we want the not equal to, the less than, or the greater than for this? And so we always look at the alternative hypothesis and what sign we used in there. We used a not equal to sign. So you want to choose the first choice, not equal to P2. And then go ahead and arrow down to calculate and hit enter. That's going to give us a Z of 1.26 approximately, and a p-value of 0.2088. Okay. So we need to compare that p-value to our alpha. And the alpha in this case was the 0.01 level of significance. So our alpha is about 1 penny. And our p-value is about 21 pennies. So our p-value is definitely bigger than our alpha. So I'm going to say p-value greater than the alpha. So in terms of what decision we should make, if your p-value is high, let the null fly. So let the null fly means we need to fail to reject our null hypothesis. So the decision we're making is fail to reject. And then what is our conclusion then? So if we fail to reject, we're going to say there is not sufficient evidence at the, and then we have a 0.01 level of significance. So that's going to be the 1% level. Okay, so there's not sufficient evidence at the 1% level to suggest that there is a difference in rates of changing majors between psychology and business. So in this scenario, because it was failed to reject the null hypothesis, there is not sufficient evidence to suggest, and we come back up to the alternative hypothesis, that there's a difference between these two proportions. And those proportions, we're talking about the rates of students changing their majors for psychology and business students.